Hello. Daily Math Blast 15. Two-step word problems. Sarah put 43 books on the shelf, and the librarian put 44 more books on the shelf. Ralph came behind them and knocked 29 books off the shelf. How many books are still on the shelf? So our first thing that I'm going to do is I'm going to write a number sentence or an equation that matches the story. So Sarah put 43 books on the shelf. So 43. And the librarian put 44 more books on the shelf. Plus 44. Ralph came behind them and knocked 29 books off the shelf. Well, knocking takes them off the shelf, so that operation is subtraction, 29 books. So trying to find how many books are still on the shelf. I'm going to use a place value chart to solve this problem because I feel like it matches the story, but remember, your strategy could differ from mine. So I have tens and ones. So now I'm just going to follow the story. So Sarah put 43 books on the shelf. So 3 ones and 4 tens. So you can kind of think of this as my shelf. The librarian put 44 more books on the shelf. So 44 more books. So I'm going to put more books on my shelf here. 4 ones and 4 tens. Now, Ralph came behind them and knocked 29 books. So I'm going to take away 29. So the first thing I need to do is take away 9 ones. So 1, 2, 3, 4, 5, 6, 7. So I have 7 here. Well, I need to cross off 9, so I do not have enough ones right now. So what I'm going to do is I'm going to come to my tens. I'm going to take a 10, and I'm going to unbundle it. And 1 10 is equal to 10 ones. 2, 3, 4, 5, 8, 9, 10. So I have my 10 ones. Now I can cross off 9. So 5, 6, 7, 8, 9. That's just a little faster way when I'm crossing off a lot of them. Now I could still use my diagonal if I want. Now I need to cross off 2 tens. And now I'm going to count what's left of my place value chart. 1, 2, 3, 4, 5, 6, 7. And I don't want to forget this one, 8. 1, 2, 3, 4, 5 tens. So 5 tens, 8 ones is 58. So how many books are still on the shelf? 58 books. So remember, the key to this is when you're writing your number sentence or expression to match the story, and then just to choose a strategy that works for you. Add and subtract within 20. So I have 13 plus 5 and 16 minus 7. Remember, the same thing, you can use any strategy that you want. We would like you to show some work so we have some idea how you're coming up with that answer. So 13 plus 5, I'm going to kind of think of this when I'm doing this in my head or mentally, I'm kind of looking at this as a unit form problem. So I can think of 13 as 1 10, 3 ones, and now I'm adding 5 more ones. So remember, ones to ones, tens to tens. So 3 ones plus 5 ones is 8 ones, and then 1 10. So 1 10, 8 ones, or 18. So that's one way of kind of thinking when I'm looking at 13 plus 5. Now 16 minus 7. So this one I'm going to kind of use the take from 10 strategy. So I can decompose my 16 into a 10 and a 6. Now the reason I want to do that is I'm going to look right here, 10 minus 7. So I'm going to do 10 minus 7. So that's 3. And now I need to add this 6 back in there. So 6 plus 3 is 9. So I'm looking at 16 minus 7. Kind of what I'm saying is, well, I know a 16 is 10 and 6. So 10 minus 7 is 3. And then I add the 6 back on. So that takes me to 9. Line plots. Record the measurements onto the line plot. So I have these measurements right here. Now when I'm creating my line plot, The two pieces of information I need is my smallest and my largest number. So if I'm looking through here, 6 is my largest number and 3 is my smallest number. So I have to include those. Now I could go smaller, so I could start at 1, but I have to include 3 through 6 on my line plot. I'm going to start here. I'm going to say 3 inches, 4 inches, 5 inches, 6 inches, and I'll put 7 inches here. Now the other thing I want to try to do is keep these spaces relatively equal because they are each 1 inch apart. So remember, you could have different numbers on there as long as you have 3 through 6, because this is the part where I'm going to record my data. Now when I'm recording my data, I'm going to use X's. I'm going to stack them on top of each other. While I'm doing this, it's important that my X's stay approximately the same size, and any space between them needs to be very consistent. So I don't want really big spaces, and I don't want that space to kind of vary a lot as I'm going. So 6 inches, cross it off, put my X above 6, 6 inches, cross it off, put my X above 6. So you know, my X's are about the same size. They're not perfect. 3 inches, 3 inches, 4 inches, 4 inches, 4 inches, and 5 inches. Okay. So I've recorded all my data. Now I don't have any questions, but the purpose of a line plot is to be able to organize my data to be able to quickly compare how often a certain measurement occurs. So if I'm looking at my data here, if I want to know which measurement happened the most often or the most frequent, it was 4 inches. On my data, which two measurements happened the exact same amount of time, 3 inches and 6 inches. And of my data, which one happened, what was the, how many more times did 4 inches happen than 5 inches? Well, 2. Because they each happened, you got the 1, and then this one goes 1, 2 higher. So this is the purpose behind a line plot, is to be able to quickly compare the occurrence of data. Measure length 2 different ways. So measure the caterpillar. So we have paper clips and ladybugs. Well, if you look, we have the paper clips, which are longer than the ladybugs. So it's going to take different amounts of each thing to equal the length of the ladybug. And we are going to measure to the nearest whole paperclip and nearest whole ladybug. So if I'm looking, I can kind of visualize this coming up. There's 1 paperclip, here's 2 paperclips, and there's a little piece here. I have to determine, is it closer to 2 or to 3? Well, I think it's much closer to 2. So 2 paperclips. Now the same thing with ladybugs. Here's 1, 2, 3, 4. So very close to the end there. So 1, 2, 3, 4 ladybugs. So notice when we're measuring, if we measure using a smaller unit, it takes more than if we measure with a longer unit. Partition a rectangle into rows and columns. Hannah is making a pizza for her family. She wants to partition the pizza into 3 rows and 2 columns. How many same-size pieces of pizza will Hannah have? Well, I have 3 rows and 2 columns. I like to put this little piece of information right here to the side. So I make sure, and I kind of double check, 3 rows, 2 columns, because that's the part that's easy to get confused. Now, when I'm slicing up my pizza, I have to remember rows go side to side and columns go up and down. The other thing I have to remember is every time I make a slice, so if I slice it here, I'm making, so notice I have a row here and a row here. So 1 slice makes 2 rows. So if I need 3 rows, I'm going to make 2 slices because I sliced here, I had 2, and then when I sliced this one, it gave me my 3 slices. Now 2 columns. To make 2 columns, I'm going to make 1 slice. I'm going to come here. I make my 1 slice, because when I cut it here, I make a left and a right. So that's why it's 2. Now I need pieces or units of pizza? Well, I have 1, 2, 3, 4, 5, 6. So there are 6 pieces or units of pizza for Hannah. This is Daily Math Blast 15. Thank you.